This is Geometry Practice Quiz 7.1. This quiz is all about the Pythagorean theorem. The first one is kind of a tricky one because a lot of students will think, oh, the hypotenuse is usually in the top right. That's not always true. It's the longest length, and this length is technically the longest, but the surefire way to make sure that you're always trying to find the longest length is just the one across from the right angle. The right angle is right here. If it go all the way across, that will be the hypotenuse. X is the hypotenuse. When I'm setting up, a squared plus b squared is equal to c squared. C squared is assumed to be the hypotenuse, and a and b are assumed to be the interchangeable legs, which means it doesn't matter if I put 5 there or 5 there, but x has to go right there. So let's go ahead and set this up. I have a 5 squared plus a 12 squared. That's going to be equal to an x squared. Let's go ahead and square the 5. I get 25. Square the 12. I get 144. That's still equal to an x squared. Adding these together, I get 169, which is equal to an x squared. And then from here, I'm going to square root both the left and the right. Technically a plus or minus, but it doesn't make sense in the world of geometry to have a minus length, so I'm going to kind of ignore that. And then from there, I'm going to get an x is equal to the square root of 169, which is actually just 13, and I get my final answer. Let's go ahead and check the answers over here. I do get number 1 is 13. All right, and number 2, again, you're trying to find the missing side length of the triangle. Just as a reminder, the Pythagorean theorem, all it can do is find sides of a triangle. It can't do angles, it can't do areas, it can only do sides. And because we're asked to do sides, you apply the Pythagorean theorem and you're done. Remember that you're still using that trick that you have a 90-degree angle. Across from that must be the hypotenuse. X must be the hypotenuse. So setting up our Pythagorean theorem, we have the following problem. We have 5 square root of 2, which is one of the legs, which I will then square. I'll add it to the other leg, 7, and square it, and that will be equal to the hypotenuse, x squared. We have them all squared, and it's time to move on. So remember that when I have a square that is above both a square root and a non-square root, you just distribute it to both of these, and you get 5 squared plus the square root of 2 squared. And I'll keep going on with the problem. I still have plus 7 squared, which is 49, which is equal to x squared. From here, though, I'm able to cross some things out. I can cross off the square root and square, which means I'm going to be left with, why did I put a plus here? I don't know what I'm thinking here. This used to say 5 times the square root of 2, and I randomly put 5 plus the square root of 2. So I need to undo that. That is my bad. This should be times, and I'll put a little dot here so I remember. That is supposed to be multiplied by. 5 squared is 25. That's going to be times, and then the square root and square cancel each other out, leaving me with a 2 plus 49 is equal to x squared. And 25 times 2 is 50 plus 49 is equal to x squared. And then finally, 49 plus 50 is a 99, which is equal to our x squared. Finally, it's time to undo the square root, so I'm going to take the square root, and then you do have to technically do a plus or minus. But again, it doesn't make sense for us to have a minus sign when we're in geometry land. You can't have a negative length. For all of Pythagorean theorem, you really don't have to do the plus or minus, but I just want to get you prepared for Algebra 2. If you see a plus or minus, you kind of know where it comes from. And I now need to do a factor tree for root 99. Like, how do I do that? This wants our answers in simplest radical form, which means I need to reduce that radical, simplify that radical. So I'm going to come up here and make a factor tree. For 99, if I take the square root of that, that's equal to the square root of 9 times the square root of 11. And the square root of 9 is just equal to 3. Like, that's exactly equal to 3. So my final answer here is going to be 3 root 11 for my final answer. All right, number 2, 3 root 11. Number 2, 3 root 11. We are on the right track. Number 3, again, Pythagorean theorem, opposite of the hypotenuse is going to be, or sorry, opposite of the 90-degree angle will be the hypotenuse. So that means that x and 7 are the legs. X squared plus 7 squared, those legs squared are equal to the hypotenuse squared. The hypotenuse is the root 257, and that is all going to be quantity squared. From there, I'm going to go ahead and square things. I can't square the x, leave it x squared. The 7 squared is 49, and that's going to be equal to, again, square root and square cancel each other out, and this is going to be just 257. From here, I'm going to subtract 49 on both sides of the equal to sign. That means I have x squared by itself, and on the right-hand side, I have, what is that going to be? It's basically subtracting 50. So I'm going to go ahead and subtract 50. I'm going to get 207, but I need to add 1. I get 208. I add 1 because negative 50 plus 1 is negative 49. So I have x squared is equal to 208, and then I'm going to do the plus or minus square root on this side, the plus or minus square root on this side. Again, it doesn't make sense to have the negative, but I'm still getting into the habit of always writing the plus or minus every time I need to take a square root. And that means x by itself is going to be equal to just the positive version of root 208. We need to write our answer in simplest radical form, which means it is time to make a factor tree. And I have plenty of room to do that down here. This one is a little bit tricky. I can see 16, but I don't think a lot of people see 16 as one of the factors. So here's how you do this if you had no idea what the factors of 208 were. I'd be like, 2. Like, you start small. You say, okay, the square root of 2, and then you can divide each of these digits by that number. The reason I knew that it was divisible by 2 is because the last digit is even. If the last digit is even, it is always divisible by 2. So I can divide each of these digits by 2. 2 divided by 2 is 1. And then 0 divided by 2 is 0. And then 8 divided by 2 is 4. So 104. And then you can kind of do the same thing again. You're like, hey, that last digit is still even, Mr. Stendel. You must be able to factor out another square root of 2. And you would be right. And then you would say, okay, well, I can't divide 1 by 2, but I can divide 10 by 2 and I get 20. Sorry, 10 divided by 2 is 5. And then I can divide 4 by 2 and I get 2. So 52 must be half of 104. And then you keep doing this over and over again. You're like, wow, the last digit is still an even number, which means I have a factor of root 2 that can pop out. And again, I'm going to take half of this. Well, half of, this is the way that I do this in my head. I'm like, well, half of 50 is 25. And this number is a little bit bigger than 50. So this factor must be a little bit bigger than 25. And it is indeed 26 for one of the factors. And then it's like, oh, that last number is still even, which means, whoa, I did not mean to switch to algebra 2 there. I meant to just do an undo button. And then from there, this again, root 2, and then divide by 2, divide by 2. It's going to be 1, 3, so 13. So it's going to be root 13. All right, so the way that I usually analyze this is that I say 2 times the 2 is going to be root 4. 2 times the 2 is going to be a root 4. So I have square root of 4, which is exactly equal to 2. Square root of 4, which is exactly equal to 2. And I still have this leftover square root of 13. So here's my final, well, almost final answer. I have 2 times 2 times the square root of 13, or the final answer of 4 root 13, which I will then box. 4 root 13 for number 3. 4 root 13 for number 3. All right, then we move into what I consider to be slightly easier problems. It's less math and more of an analysis. Just as a reminder, what we're essentially going to be doing is we're going to be doing something like let me write over to the left. A squared plus B squared is equal to C squared. And if these are perfectly the same as if they're tied for the size of the numbers, if they're tied, then it's going to be a right triangle. If the right side is bigger, then it's going to be obtuse. So if the right side is bigger, I'll say if the right side is bigger, it's going to be obtuse, and vice versa, it's going to be left. And just as a way to make this make sense, we've already proven the Pythagorean theorem in class. So we know that a tie means it's a right triangle. But why does, if the right side is bigger, if this side is bigger, why is it obtuse? And I feel weird using the word right because technically I can switch the left and the right sides and they're still the same Pythagorean theorem. But if you always set up like this, then the right side being bigger means it is obtuse. Why? This is the hypotenuse. This is the hypotenuse. Can you visualize what would happen to this angle right here if this gets bigger and bigger and bigger? If this got really, really big, and then these side lengths stay the same, what would eventually happen is it would go like this. It would get bigger like this, and this angle would get really, really big, aka obtuse, which means bigger than 90 degrees. And vice versa, if these lengths got bigger and this length stayed the same, what would happen is it would come into something that looks like that, and this angle would get really small. And then therefore it'd be an acute triangle, meaning all of the angles in the triangle are less than 90 degrees. So now that I've kind of given my brief explanation from our notes, just go ahead and set it up. I'm going to say small squared plus small squared equals big squared. How do you know it's big? Okay, if you're watching the video, I'm going to give you this hint. On every single quiz, test, final, whatever, I'm going to have a part of the triangle that looks like a 90-degree angle right here. It's always going to be across from that. That's going to be the biggest length. Some of that, like, well, this one is clear. Like 10 is obviously bigger than 8 and 6, but some of these are not so clear. Like if I look at maybe this one, like 2 root 15 and 20, which of those is bigger? I mean, you can eyeball it and be like, well, that one looks bigger, but eyeballing it is tricky because I purposely try to trick you. So let's go ahead and just do a math problem instead of talking. Okay, 8 squared plus 6 squared equals 10 squared. 8 squared is going to be 64. 6 squared is going to be 36 is equal to 100. Add these together, get 100, and that's equal to 100. Oh, okay. If it's a tie, if the left and the right are equal to each other, then this is going to be a right triangle. So I'll say right, I'll box it, and then I'll check my work. So number 4 is a right triangle. Number 4 is a right triangle. Yeah, these problems are much faster and easier than the previous problems, I would say. All right. Again, this is the right angle, maybe, and then that means opposite of it is going to be the large one. That must be the hypotenuse. So I'm going to have root 230. I'm running out of room here. I'm going to say, whoa. Root 232 quantity squared plus 5 squared is going to be equal to 16 squared. Let's see which side wins. All right, the square and square root cancel each other out, leaving me with 232, and that's going to be plus 25, and that's going to be 256. If you don't know your squares, you can always use a calculator or use a multiplication table. Adding the left side together, I get 257 is equal to 256. Oh, wow, that was so close. Just barely, the left side won by just 1. Which is like, what is that, 0.05 or 0.5%, just barely. And again, if I say that the left side wins, it's acute. So this one is going to be a cute little triangle, you know. Number 5, acute. Number 5, acute. Please, yes, there it is. And number 6, I already saw the answers by accident. It's going to be obtuse. So number 6 is right here. We're on to the second page. This one's a little bit tricky just because I have a mixture of radicals and non-radicals in the same problem. But I know that this would, in theory, be the right triangle, or the right angle, so across from it must be the largest angle, because I have Mr. Sundell's hint. So 2 root 15, whoa, what happened there? 2 root 15 is one of the legs squared plus the other leg squared. I'm using the word leg, but that only applies to a right triangle. I should say small squared plus small squared is equal to big squared. Big squared. And just remember that the 2 gets distributed to both of these. So I'm going to have a 2 squared times, not plus, times the square root of 15 squared. It's going to be plus 196. It's going to be equal to 400. All right. And just as a reminder, square root and squares cancel each other out. So this is going to be 4 times 6. Do I want to say 16? 15 plus 196 is equal to 400. And 4 times 15, I don't know how to multiply by 4, but I know how to multiply by 2 twice. So multiply 15 by 2, 30. By 2 again, 60. So it's going to be 60 plus 196 is equal to 400. And then from here, I'm going to get 256 is equal to 400. And the right side one, if the right side wins, that's going to be obtuse. So I'm going to say obtuse. And if you ever forget which one is obtuse, visualize what's happening. That represents the hypotenuse. Stretch the hypotenuse out and see what's going to happen to the angle over here. Obtuse, final answer, box it. Hopefully we get it correct. It would be embarrassing if I got that one incorrect, but it happens. Number 6, obtuse. Excellent. All right. These next values, number 7, 8, and 9, I just kind of looked at the answer key. I'm like, oh, there's decimals in our future, which means calculators in our future. And it makes sense, too, when I read the instructions because it's asking us to round, et cetera, et cetera. And we're rounding always to the nearest tenth. And I talked to Claire in class from today, and she was off by a little bit. If you're off by a little bit, I'll still probably give you the full points as long as the answer is not super far off and there's no gaping mistake in your work. So let's go ahead and figure out what's going on. We're trying to find the area. The way that we find area of a triangle, if you have forgotten, area is equal to, I guess you multiply the base times the height, and then after you're done doing that, then you divide by 2. We explained multiple times why you do it in class, but the general idea, once again, is you're trying to think of this thing as a rectangle. Rectangles are simply base times height, and then because this is a triangle where we cut it in half, we divide it by 2. That's the same thing as cutting in half. So what we need is a base and a height. We don't have a height, we have a hypotenuse. So somehow I'll find the height, then I'll use the formula, and then be done. Ready, set. I'm going to go ahead and call this thing x. Once I solve for x, I can plug it into our formula for the area of a triangle. To find x, which is a side length, I'm going to be using Pythagorean theorem. This is the hypotenuse because it's opposite of the 90-degree angle. So I'm going to have x squared plus 6 squared is equal to 12 squared. So it's going to be x squared plus 36 is equal to 144. And then from there, I'm going to subtract some things. I'm going to subtract 36. That's going to be 108, I believe. And that's going to be equal to x squared. And normally, well, I mean, you have to square root no matter what. I was getting to my next step. When you square root, you get x is equal to root 108. Normally from here, my instructions would say you need to have simplified radicals, but I said to round your value. So from here, you just pull out a calculator. You're kind of done with that step. You're not done with the final answer because I still need that formula. So now is when I'm going to approximate, and that means x is going to be approximately equal to, which is like a wavy equal to sign. It's not an equal to sign that is straight lines. We're approximating. So I read this as x is approximately a number. So let's go ahead and open up our calculator. I'll use a scientific calculator. Let's clear all that stuff. Calculator, you're going to go on the left. Notes, you're going to go on the right. I don't need you to be that big. All right, I'm just going to type in square root of 108, and I get about 10. Oh, wait, I should do this in pen. 10 point. Okay, it said to round to the nearest. You guys all read this. Round to the nearest tenth, which means 1 decimal place. So instead of saying 10.3, I'm going to round that up to 10.4. That's 1 decimal place. All right, so I have 10.4. I'll go ahead and write that there. 10.4, and then again, I'm just doing 10.4, which is the height. I'm going to multiply that by the base, which is going to be times 6, and then after that, I'm going to divide by 2. So I'm just going to say 10.4 times 6 divided by 2, and I get, this is again 31.2. So that's my final answer. There are no units on this one, so I can just leave the numbers. 31.2 for number 7, 31.2 for number 7. All right, number 8. It's going to have a few more steps, and number 9 is going to have a lot more steps. I'm assuming that's how I try to set it up. All right, again, if I have base times height, then I'm done. I'm missing part of the base, and I'm missing all of the height. So I need to find those values. I'm just going to label them randomly. Let's call that one x. Let's call this piece only right there y, because I'll have to add y to 4.6 to eventually find stuff. All right, I see one big triangle that I don't really know how to work with because it's not, that one big triangle does not have a 90-degree angle, but I have 2 right triangles. Let's go ahead and write both those right triangles and figure out which one we want to use. So in the first triangle, I have a triangle that looks like that, and then I also connect it, there we go, and that's a right triangle right there, and I have another right triangle over here. Let's go ahead and label everything we know. We know that this is 5, and that's the only thing that we know. We know x and y, but we don't actually know their values. The other triangle I know is 5 and 4.6. I think we're going to start on this triangle because it has more information. Usually with a Pythagorean theorem, you'll have 2 pieces that you do know and 1 piece that you don't know. So that's why I'm starting with this one. This one has too much unknown values. So I'm going to find that length right there, which we have apparently labeled x. So x is going to come over here. I'm not doing this triangle because I labeled it x. I'm doing it because it has more information. So let's go ahead and label you x and then set up Pythagorean theorem on that left triangle. The triangle is going to say 4.6 squared plus 5.0, or 5 squared, and wait, no. It's going to be leg squared plus leg squared. I was doing leg squared plus hypotenuse squared, so that needs to change into an x. My bad. This is going to be x squared. It's going to equal to 5 squared. Now I have the hypotenuse. The hypotenuse across from the 90-degree angle is on the other side of our equation. All right, I don't know what 4.6 squared is off the top of my head, so calculator 4.6 squared, so I'm going to have 10, I'm going to have 21.16 plus x squared is equal to 25. From here, I'm going to subtract 21.16 minus 21.16 minus 21.16 on both sides. You're gone. X squared is by itself, and this is going to be equal to, what is that going to be? I'm going to be lazy. I'm going to just say 25 minus answer, and I get 3.84. And then from here, I'm going to square root you, and I'm going to get x is going to be approximately, well, I mean, it's going to be exactly equal to, it's going to be exactly equal to the square root of 3.84, but I don't know what that is, so I'm going to approximate that. I'm going to say the square root of our answer is about, oh, you have to be careful here. I wanted to write 1.9, but that's incorrect because the next number here is a 5, which means that this 9 has to be rounded up to a 10, which means it's really 2.0 is how I would round this. So you are gone. This is a 2.0. So I'm going to go ahead and label you on our triangle, maybe in a different color. This is going to be equal to 2.0. And that means that this is a 2.0, which means this is a 2.0. And hey, now we have two known values and one unknown value. So let's go ahead and say that unknown value we've already labeled as y. Let's go ahead and figure out what y is. To find y, I'm going to say 2 squared plus 5. I'm doing the same thing again. 5 is the hypotenuse. I need to put that on the other side. I need to see the other leg is actually y. So 2 squared plus y squared is equal to our 5 squared. And I know what 2 squared is off the top of my head. 2 squared is 4. 4 plus y squared is equal to 25. From there, I'm going to subtract 4, and y squared is going to be equal to 21. From there, I'm going to square root, technically plus or minus. I should have done the plus or minus over here, but it doesn't make sense to do plus or minus in geometry land because everything is positive with length, especially with Pythagorean theorem. So when we deal with circles, that will change. Circles can have negatives and positives because they'll be all over the coordinate plane. Y is going to be equal to the square root of 21, just the positive version, and I don't know what the square root of 21 is off the top of my head. A little bit less than 5 because square root of 25 is 5, so 21 is going to be about approximately equal to 4.6 because that is 5/8 and that rounds a 5 up to a 6. So I have 4.6. I come back to my diagram and say that this is equal to 4.6, which is weird because that was 4.6. I guess this was nearly I guess it was an equilateral triangle because that was a 5 and that was a 5, now that I think about it. Anyway, we get 4.6, which means I need to find the entire base. Whenever you have two different lengths, you add them together to find the entire length. So I'm going to do the following. The area of our triangle is going to be base times height, and then divide by 2. The base here is going to be 4.6 plus 4.6, so that's the base. And then the height here, we said was 2. So that's going to be times 2. That's going to all divide by 2, and check this out. Here's a little math trick. You 2 are gone. I just have to do 4.6 plus 4.6. I can do that in my head. That's 9.2. So I get 9.2 for my final answer. 9.2 for the area. 9.2 for the area. And on to our final question, which is the answer is 74.3 for whatever it is. Let's see if I can remember that. Number 9. How do we do number 9? Wow, a lot of stuff to unpack here. Again, we're searching for the base. There's going to be like a ton of steps on this one. My goodness. I'm going to start by drawing the two different triangles. I think that's going to really help us. I have a triangle that looks like that, the right angle, and I have a triangle that looks like that, a little bit skinnier, like that. That's a right angle right here. On the first triangle, I know that's 11 and 14. On the next one, I just know that's 12. I can't even use this triangle because I need two pieces of information. So you are useless. You, however, are going to be useful because you have two pieces of information, which means I can find you. Let's label you x, which means that length right here is x. And I can find x right now. So I'm going to say leg squared, 11 squared, plus the other leg squared, x squared, is going to be equal to the hypotenuse squared, 14 squared. 121 plus x squared is equal to 196. Subtract 121, subtract 121. And I get x squared is equal to, what is it going to be, 75. Then from here, I'm going to square root both sides, square root, and I get x is equal to square root of 75, which I don't know off the top of my head. Calculator, help me out. Square root of 75 is about roughly 8.7. I'm rounding. It's not 8.6. We're rounding up to 8.7. Cool. How does that help us? It doesn't. Oh, it does, but I just realized I've made a mistake. So there's a mistake on the screen right now. If you can find it before I say what it is, you can log the extra credit. All right, now that you're done pausing me, here's the, oh, by the way, if you just listen to me say what the error is, that doesn't count as extra credit. Here's the mistake if you caught it. This 11 is here, but that 11 should have also been right there. That's the mistake. I did have enough information on that second triangle. I said earlier that I didn't have enough, but it's because I mislabeled the triangle. I do have enough. I can find that length right now. I could have found it first. So that length I'm going to call y, just to give it a name, and I can start by finding y. The way that I'm going to find y is I'm going to say that leg squared plus leg squared is equal to hypotenuse squared. And then from here I can solve. I have 121 plus y squared, and that's going to equal to 144. I'm going to subtract 121, subtract 121. It's going to be y squared is equal to 23, and then I'm going to square root, y is equal to square root of 23, which I don't know off the top of my head. A little bit less than 5. I'm going to say 5.8. Let's see. Square root of 23, or 5.8? 4.8 is what I meant. Man, I'm off. 4.8. I knew it was less than 5. For some reason, my brain wasn't working. 4.8. So that means that this length right here was y, and we actually know those lengths. This length was 8.7, and this length was 4.8. So altogether, if I add those together, I get 13.5. So altogether, this entire, I'm running out of room here, but if I just add these two together, I get 13.5. So I'm going to say the area of a triangle, I'm going to do over here, area of a triangle is equal to base times height over 2, which in this case the base I said was 13.5. This number, just as a reminder, came from 8.7 and 4.8. 8.7 plus 4.8, and then it's base times height. Do we have the height? Yes, it's 11. We already have the height. Times 11, and that's all divided by 2. Punch it in the calculator, see what it says. 13.5 plus, not plus, times 11 divided by 2, and I get 74.25. I can round that up to 75, I suppose. So this is going to be, I guess I'm rounding here, so I'm saying approximately 75 for our area. Let's go ahead and check our work. Number 9. Oh, what am I doing? 75. I don't round up. My rounding is so off. I must be tired. It's Friday, guys. I don't want to have to record. No, okay. I do want to record this video. I want to make sure that you guys are prepared. It's going to be 74 point. Okay, now I round because I rounded 1 decimal place. It's not a 2, it's a 3. It gets rounded up. So 74.3 for my final answer. 74.3. 74.3. I got all of them right. Hooray. I made a tiny mistake there at the end. Yeah, that concludes all of the practice quiz 7.1 for geometry. Thanks for watching.